या अपलोड भी करना पड़ेगा क्या?
नहीं सर,
यूट्यूब में बोला था।
तो यूट्यूब में रिकॉर्ड होता रहेगा सर अपने आप से। अब आप लाइव हैं सर।
लाइव हो सर।
कुछ बोलना पड़ेगा क्या ना?
हाँ सर, चैट आएगा तो उसका रिप्लाई करना पड़ेगा।
लेकिन ये मेरा पुराना वाला वीडियो, ये पीछे की इतना स्लो क्यों चल रहा है ये?
सर डिले आता है, डिले चलता है।
ओके।
अगर कोई ऐसा फोरम का है ना सर कि फोरम में कोई क्वेश्चन या कोई प्रॉब्लम आ रही है तो वो भी वो कर सकते हैं सर।
बहुत सारे कैंडिडेट ना ये पूछ रहा था मुझसे कि वो उसको स्लाइड या पीपीटी, ये तो एनपीटीएल ऑफिस तो करेगा, ये
ये
भी।
रिकॉर्ड तो हो रहा है सर ये।
हाँ,
तो उसमें अगर वो प्रॉब्लम है वो आपको भी बता दें।
मैं कैसे बताऊं? ये तो आइदर एनपीटीएल ऑफिस करेगा ना।
पीपीटी,
हाँ,
पीपीटी से लेसन देते हो केवल डाउनलोड होगी
और
फोटो।
जो भी है तो मैं बोल दूंगा, ये कॉन्टेक्ट विद द पीपीटी एनपीटीएल।
एग्जाम का जो क्वेश्चन पेपर पैटर्न है वो आपको पता है सर कैसा
हाँ,
होगा।
ऑनलाइन एमसीक्यू टाइप ना क्वेश्चन। ऑनलाइन एमसीक्यू टाइप। सो 25, it's 100 marks question, right? And then 50
25 for recall
recall.
from assignment, and 25 from inside the PPT, and 50 outside or inside.
Related to the course.
Related to the course.
Oh, watching now. Good afternoon, sir. Good afternoon. Is nanocomposites help to change the surface modification nanomaterials? Yes, of course. Basically, what happened, nanocomposites means it's a composites where we are using certain kind of materials which are into the nanometer range, right? So basically, if you want to change the surface properties, then first you have to know that which kind of properties actually you are going to change. So suppose you want to change its thermal properties, or maybe you want to change its electrical properties, or maybe you want to change its surface texture. So based on that, you have to add different types of nanomaterials over there. So basically, nanomaterials here, it's only the do the surface changing. It is not going to change the chemical properties. So if you do any kind of coating type of materials, so automatically what will happen, it will change the material physical properties but not the chemical properties. Hello Vivek, hi, good afternoon. The exam paper pattern is basically the 100 marks multiple choice questions. So 25%, that means 25, all are the 1 marks question. So 25 marks will come from your assignment. 25 marks, it will come from inside the PPT, and another 50 it will come related to your subjects. So it will be 25 plus 25 plus 50, so almost 100. Okay, Jitendra, I got your questions. You are telling that you have started that coefficient of friction cannot be over more than 1, right? Maximum cases it is true, but in some special cases the coefficient of friction can go more than 1. Say suppose if I take the aluminum, and then if I take the aluminum and if I rub the one aluminum to another in the dry conditions, so that time the coefficient of friction is going to 1.15 to 1.25. So basically in some special cases, depending upon the conditions, environmental conditions, and depending upon the surface area, means area of contact, maybe coefficient of expansion, your coefficient of friction can go beyond 1, but maximum case basically it is within 1. Hello Gaurav, good afternoon. Good afternoon, Chaudhary. Electrochemical corrosion. Electrochemical corrosion. Jitendra, can you explain me in which slides it is there? Electrochemical corrosion. So, okay, anyway, I'm giving you the answer. So basically, in the electrochemical applications, what is happening? I am having two electrodes, right? So I am having that electrolyte. So both the electrodes are dipping into the electrolyte itself. So now after that, what happens? One atom is going from one electrode to the another. Or so in these particular two electrodes, one will be the acceptor, another will be the donor. So basically, while the electrons is transferring from one electrode to another, or maybe another electrode to opposite, vice versa one. So basically, what happened in the electrolyte system, if we are having the water, so that time basically we are thinking that when the electron is going, the material is decaying. So that basically is known as the electrochemical corrosion. So the material is corroding basically. But actually what happens? The electron is transferring from one state, one electrode to the another one. So here the water actually must be presence in terms of some kind of corrosive media over there to serve the medium for the transporting ions. So basically that is the electrolyte what I am talking about. So you are having two electrodes, you are dipping these two electrodes into the electrolyte, and the electron is coming from one electrode to the another, and it's through the electrolyte. So electrolyte may be the water or maybe some kind of electrolyte mediums. So in this particular case, the corrosion, it continues as a depolarizer, basically removes electron from the metal. So the polarizations and the depolarizations is taking place. So automatically from the one metals, the electron is coming and it is depositing onto that. So when the electron is coming, we are calling it as a depolarizations of the electrons, and due to that, the corrosion is taking place onto the electron itself. So electron chemical corrosions, the best example is that iron. So when you are dipping that iron into the water itself, so what is happening? So basically the uh, formations of the rusting. So that is known as the actually the electrochemical corrosion. Hello Dharamveer, good afternoon. Hello, Nivedita. Good afternoon. It's a good question that what are the different types of nanomaterials? In number of types, basically. Because nanomaterials means what? The materials size is into the nanoscale. So any type of material, you can make it into the nano. So if the size of that material, if you are able to make that size of that materials into the nanoscale, so it will be called as a nanomaterials. There is no specific things that it's that this material will be nanomaterials and that is not. So in any materials, if I am having this pen, right? So basically in this pen, if I make a small parts, and if any one of the parts, if any dimension will become into the nanoscale, so automatically that will be known as the nanomaterials. And now this pen is made by the plastics. So that will be the plastics nanomaterials. So any materials is possible, but maximum cases when we are talking about the nanomaterials, basically we are talking about the carbon-based materials, metal matrix composites, metal-based nanocomposites, or maybe the nanomaterials, ceramic nanomaterials, polymer nanocomposites. Actually, we are talking, that means in the polymer matrix, we are adding any kind of fillers, which fillers dimensions are into the nanoscale. So probably you have heard about the 0D, 1D, 2D, 3D materials, right? So depending upon that, what is the size? We are telling it nanomaterials. So nanomaterials is what? It's nothing, nano, 10 to the power minus 9 meter, right? So if you are able to make that materials into the 10 to the power minus 9 size, so basically we are calling it as a nano. So now generally the nanomaterials range is from 1 to 100 nanometer. So if any material lies in between the 1 to 100 nanometer and you are using that nanomaterials into some matrix, if it is metal matrix, then we are calling it as a metal matrix nanocomposites. If we are using it into the polymer, we are calling it as a polymer nanocomposites. If we are using that materials into some ceramic matrix, we are calling it as a ceramic nanocomposites. So basically this is known as the nanomaterials. Minimum size of the nanoparticles, maybe when we are talking about, basically it's about 1 to 100 nanometers. So sometimes you can see that whatever the nanomaterials you are using, so that is basically 1 to 100 nanometer range, because the best practice, basically people are using within 1 to 10 nanometers also. So basically what is happening? Nothing. When you are making the particle size smaller and smaller, so automatically its surface area will be increased compared to its volume. So when the surface area will increase, so basically the material will give you some enhanced properties. So if we talk about the 0D, right? 0D, the best example is that suppose quantum dots like GQD, graphene quantum dots. So basically the size varies in between 1 to 10 nanometer. Now, if I talk about the carbon nanotubes, so then it goes around 20 to 30 nanometers or maybe 50 to 60 nanometers. But D means nothing. D means all the dimensions. Even when I am talking about 0D, that means all the dimensions are into the nanometer range. When I am talking about 1D, so one dimension is into the nanometer range, other are into the micro scale. If I talk about the 2D, so two dimensions are into the nanometer range and others are into the micro. When I am talking about the 3D nanomaterials, so basically the three are into the micro scale and there is nothing about the nano. So basically D means nothing but that because D is coming from what? You are having the X, Y and Z. So in some cases, X may be nano, Y and Z into the micro. Y and X both are nano, Z into the micro. And some cases X, Y, Z both are into the micro. If both are become nano, so that time it is 0D. So that is the quantum dot. You see, nanotechnology is first of all, it's not any specific branch related subjects. Basically, nanotechnology is the interdisciplinary one. So being a mechanical engineer also, I am working on to the nanotechnology. So nanotechnology is doesn't means that you have to be from particular department. If you are using the nanoparticles or maybe the nanomaterials into your research, so of course you are working on the nanotechnology sides. Physics, lots of people are working. Say suppose when you are working onto the battery, when you are working onto the supercapacitor, when you are working onto the quantum mechanics. So basically if you are dealing with the nanomaterials, so automatically it will come under the nanotechnology. There are not any kind of specific research topic that this is related to the nanotechnology, this is related to the civil engineering, this is related to the physics, this is related to the chemistry. The scientists, basically those who are dealing with the nanomaterials or maybe researching on the nanomaterials, their properties, their synthesis. So basically they are working on the nanotechnology. Yes, it can be used for the LED technology also. That is called the light emitting diodes, right? The full form of the LED. So one that earlier, a few years back, maybe 5 to 6 years back, the white LED light has been invented. Then after that, people have started working
सर अभी ऑनलाइन है.
बोल देना सर, सॉरी फॉर इंटरप्शन.
Yes.
Okay, sorry for the technical interruptions. So now difference between quantum dots and the nanoparticles, right? So nanoparticles, first, if you want to the answer, so now let me know that what is the size of the nanoparticles first, and whether it is any kind of particular shapes, whether it is rod, whether it is globular shapes, spherical. So of course, if we talk about the nanoparticles, then of course it is having certain dimensions. So quantum dots is what? Basically, quantum dots is basically, we are calling it as a 0D. Do you know that how the it looks like? It's like a football. It's like a ball. It is into the nanometer range. And basically the best example is that buckyball. Basically we are calling it. So buckyball structure. So in that particular case, all the dimensions are into the nanometer range. Okay. Now, if I talk about the 1D, so that means one dimensions is into the nanometer range. If I talk about the 2D, like graphene sheets, so I am having the X, Y, and Z. So in this particular case, the two dimensions are into the nanometer range. One is into the, two dimensions are into the microscale, and one is into the nanometer range. So that's why it is called the 2D materials. So basically 0D, 1D, and 2D dimensions are known as the nanoparticles, and the 3D basically it's not the nanoparticles, because here all the dimensions are into the microscale. So 3D is like out of the box. I'm sorry, because I don't have any answers of this one. What is the difference between OLED and ILED? Because I don't have much experience on that. Basically, it's not my specializations also. So I cannot say anything about this OLED and ILED. So basically, nanomaterials which are using for the LED productions, I guess the materials should have the good electrical conductivity. It should have some photoluminescence or maybe the fluorescence property. That kind of nanomaterials can be used for the LED productions. Maybe I am not specialized. I haven't done any work onto the LED materials. So maybe the germanium or silicon. Silicon is a good one for the solar thermal, because solar thermal I know people are using the silicon, amorphous silicon, then single crystalline silicons tremendously for the solar cell fabrications. So maybe it can work, but I am not sure about that one. Yes, there are lots of materials people are using for the solar cells. For, say, suppose people are using the titanium dioxide as a solar cell materials. Now, solar cell is not that it is made by only a single materials. Because if you know about the solar cells, there are people are using so many layers over there. So basically, the each layer the materials are different. So basically, for the solar cell nowadays, people are using the perovskite materials, say like CH3, NH3, PBI3. So like this, basically they are using instead of I, that is the halide group. People are using maybe the bromine, maybe the iodine, or maybe some kind of others halide group over there. So peroxide solar cells are there. Silicon materials is widely used. People are using the lead materials, lead related materials also. So there are lots of materials basically people are using that which can give you the electricity, because basically the solar cells means what? From the heat. So if the photon is coming and then that photon is converting into the electricity. So basically the people are using so many nanomaterials. So basically that can absorb the photons, and then the electron will transfer from the electron layer to the whole transport layer, because there are two layers. One is acting as a electron acceptor, another one is acting as a electron donor. So basically it's a sandwich kind of things. So which material? Dharambir, for your questions, I can give you that radar absorbing materials, basically the materials which can absorb the electromagnetic radiations. So if you are having that electromagnetic radiations materials, so basically it is called the RAM, actually, radiation absorbent materials. So basically that RAM materials should have that it can capability that it can absorb some signals, it can absorb some electromagnetic waves. So now you can use certain kind of nanomaterials which just increase the efficiency of those radar absorbing materials. Thank you, Jitendra. Thank you very much. I guess you people are enjoying that surface engineering subjects. If still you are having any questions or maybe anything comes in your mind, so you can share it into the forum so that we'll give our 100% to give you the satisfactory answer. It's a good one that why titanium dioxides nanotubes are used for the solar cells. Basically, the solar cells, if you see that titanium dioxide, we are using one layer. So basically, in between the electrode, when the sunlight is coming, that photo, then the titanium oxide is having that ability that it can allow the electron to go from one layer to another layer. So basically, titanium dioxide people are using for the whole transport layer. So whole transport is nothing but one when it's a one kind of thinking that when the electron is coming from one place to another place, or sorry, when the electron is going from one place to another place, so electron is going from here to here, right? And then it is creating certain kind of whole transport hole over there. So if the electron will go in this manner, so hole will move in this manner, then only the balancing will be taking place. So basically that titanium dioxide is having that ability that it can allow the electron to move from one place to another. So that's why nowadays people are using titanium dioxide widely. But there are so many other materials also available, so which can be used for the solar cell applications. As I told already, nowadays people are using the peroxide materials. So if you listen me carefully, I have talked about the perovskite solar cell materials, which is nothing but the CH3, NH3, PbI3. So these kind of materials nowadays people are using for solar cells. Okay, thank you very much. Thank you very much for attending my live sessions, and I hope you are enjoying the surface engineering of nanomaterials. I hope that I am able to give you the satisfactory answers. Still, if you are having any questions left, so you can discuss into the forum. We'll try our level best to give you the satisfactory answers. Thank you very much.
That means not a complete